Welcome back to Maths with Mrs. J. Today I want to talk about Pythagoras' theorem. Now, Pythagoras was a Greek mathematician who lived about 500 BC, so that's an awfully long time ago. And he came up with a rule about right-angled triangles. I've drawn a right-angled triangle here that you can see. Let me just get there we go. So what he said was that in a right-angled triangle, the square on the hypotenuse, so c squared, is equal to the sum of the squares on the other two sides. So in formula form, we could say a squared plus b squared equals c squared. There is a cool little 30-second video if you would like to look at that later on. It shows how you can cut this up to put onto here and here and show that that area is exactly the same as these two areas. What it basically involves is cutting out a b squared out of the middle and then cutting the rest into 4 pieces and rearranging them. The important thing here is that you need to note that you have to have a right-angled triangle in order to use it. If for some reason you have a triangle that is not right-angled, you might need to do what we call dropping a perpendicular. So we might need to create some right-angled triangles. The other important thing that you need to know is you need to be able to recognise which side is the hypotenuse. Now, usually it's fairly easy to see. It is the longest side, of course, but if you're ever in any doubt, some triangles, it can look a little bit iffy sometimes. It's always going to be the side that is opposite the right angle. So that's very important in order to do that. All right, so we're going to start with some examples and move to our next slide. Okay, so let's just start with some fairly basic examples. We're working with right-angled triangles. All right, we're checking that, that's important. And in this circumstance, in both cases, we are finding the hypotenuse, that x happens to be the hypotenuse. Let's do these examples together. Now, always good idea to write a rule. If you have a rule, write the rule. So let's start with this. So a squared plus b squared equals c squared. And I like to give credit where credit is due. Pythagoras should be given his due credit for that rule. All right, now we're going to do our substitution step. Now, it does not matter with your two shorter sides which one you call A and which one you call B. I'm going to call A the 4 and B the 3 centimetres. As I said, it doesn't matter because 3 squared plus 4 squared is the same thing as 4 squared plus 3 squared. Now, if these were decimals, particularly if they had lots of decimal places, once you square them, you're going to get even more decimal points. And you probably don't want to be writing all your interim steps. I would say it's probably okay at this stage to either use a calculator to work out what that equals, or if you happen to know, well, in this case, it's 16 plus 9, isn't it, which is 25. So I would say that that's okay to do that either with a calculator or with just your general knowledge about perfect squares. Now we want to find x. Currently it's been squared. How do we undo squaring? We undo squaring by taking the square root. What is the square root of 25? We can either use a calculator to do that. That button is probably above your x squared button, so you'll do second function x squared button, and you'll get 5. We should put the correct units. Now, technically speaking, if you are presented ever with a situation where you get x squared as 25, what is x? Technically, there are actually two answers to that. Positive or negative square root of 25. because 5 times 5 is 25, but so is -5 times -5 also equal to 25. So normally speaking, if we have this situation, we will get 2 possible answers. However, in this case, when we're working with Pythagoras' theorem, it is perfectly reasonable, in fact, sensible, to just take the positive square root because we're talking about a length of a side of a triangle. We can't have a negative side length. So just be aware of that at that stage there. All right, let's do another example. Same sort of thing. So again, we start with our formula. All right, again, doesn't matter which one you call A and which one you call B. We're just subbing in. Now this is the point where I'd probably just plug that into my calculator. 4.7 squared plus 10.2 squared equals, and you get 126.13 is our x squared. Then again, just to remind you to undo the squaring part, we're going to take the square root. And we have been asked to round off to 2 decimal places. So when we do that, we get about 11.23. I might put the x over here, is approximately that. For your approximate sign, you can either use that or you can use that. Or you could say x equals 11.23 to 2dp. But don't just say x equals 11.23 because it's not exactly equal. Alrighty, let's move on and have a look at the next slide, next lot of examples. Okay, these are very similar, except in this case, the x happens to be on one of our shorter sides. Now, some people learn separate rules for whether they're finding the hypotenuse or one of the shorter sides. I personally think that's a little bit unnecessary, and I just use the one rule and know how to manipulate it appropriately. So let's do that. We have a right angle triangle, so let's use Pythagoras' theorem. So a squared plus b squared equals c squared. Good old Pythagoras. All right, subbing in. Now in this case, we can let our a be x. Now, our aim is to get the x on its own. So the first step involved in that is getting rid of this plus 5.8 squared. So I would go from that step to this step. There's a little bit of algebra here. We're taking away 5.8 squared from both sides. Now, as I said on the previous slide, I personally would plug that into my calculator at that stage. 12.1 squared minus 5.8 squared, and you get 112.77 is our x squared. All righty. Now we're at the point where we're going to take the square root and we're going to round off to 2 decimal places and you get 10.62 centimetres. Just checking, does this make sense? Well, yes. If we'd got a value that was bigger than our 12.1, that would be a concern because 12.1 is our hypotenuse, isn't it? So that's got to be the longest side. So yes, that does make sense. Just do one more quickly. Just subbing in, so we write our rule, we sub in, we get our x squared on its own. So we get here x squared is 3219.84. I'm not that quick with my calculator, by the way. I'd already worked these out before. So x will be the square root of this. Rounding off to 2 decimal places, and we get about 56.74, I believe. Again, just checking, that is less than our hypotenuse, so that's all good. Alrighty.